I gave Claude a task I had done 100 times. Just dedupe a customer list. It came back almost right. So I did what 20 years of engineering trained me to do. Found the flaw, fed it a precise correction. The output got worse. I corrected it 3 more times, same thread. Each time more disciplined. Each time drifting further from what I needed. The more senior I acted, the worse it got. The problem was not Claude, it was the instinct I brought to it. One that has never failed me on regular code and falls apart the second you point it at AI. Two kinds of systems. Here is the difference that trips us up. Deterministic systems, the code we have been writing and debugging for decades, have a single true cause for every failure. Read the source, trace the execution, find one line where the logic breaks. Fix it, the same input will always produce the same output. AI does not work that way. The same input can produce different outputs on different runs. There is no source to read. There is a model trained on billions of tokens and its outputs are probability distributions, not function calls. Plain version, deterministic code is a calculator. Same buttons, same answer every time. AI is closer to asking a sharp, well read colleague. Ask the same thing twice and you will get two good answers that are not word to word identical. That difference is not a defect, it's a whole nature of the tool. When you bring a deterministic debugging mindset to a probabilistic tool, three of your instincts start working against you. Let me show you what they are and what I do instead. Three instincts that betray senior engineers. When code compiles, we have learned it is probably fine. When a colleague's design is directionally right, we approve it and move on. We have been trained to treat good enough at first glance as a signal. With AI, almost right is where the expensive failures hide. The output looks plausible, the structure is correct, but there is subtle assumption baked in, an edge case quietly skipped, a number that is off just enough to matter in production. The fluent, confident tone does not warn you that you are looking at a failure case. The fix? Read AI output for intent and failure modes, not just the structure. Specifically, what assumption is this making that I did not state? What would break this when the edge case I care about? Instinct 2. Trusting the perfect prompt. Engineers write precise, complete requirements. We specify edge cases upfront. We put the work into the brief so implementation does not have to guess. That discipline is good. Last week's whole point was to lean on it. A real brief beats one line keyword every time. But deterministic instinct add a second step that backfires. It pushes you to make that brief perfect and complete one big all at once prompt. You then debug when it fails, like a broken test. The iterative version took 3 shorter exchanges. Messier process, far better results. Why? Each exchange let me course correct based on what I actually saw, instead of betting everything on getting the brief perfect upfront. That variation is not a bug, it is how the tool works. So, work with it, not against it. Instinct 3. Trusting the first roll. If a test fails and I rerun it and it passes, I investigate. I do not just accept the pass. Non-determinism in tests is a bug. With AI, non-determinism is a feature. If a prompt produces bad result, running it again sometimes with a tiny tweak gives you a good one. The output is not a fixed function of input. The dice can land differently. Senior engineers who trust first run and bail when it fails are missing a ton of easy wins. So, what do you do actually differently? Three direct replacements, one for each instinct. Replace almost right is probably fine with read for intent and failure modes. Ask what assumption was made that you did not state. Find that before you move on. Replace specify everything upfront and then debug with start with first draft brief, see what Claude infers, then redirect. Treat that first output as draft, not a deliverable. Replace do not rerun non-deterministic results with rerun deliberately, vary phrasing slightly, look at two or three outputs before deciding on the direction. The extra runs cost seconds. The average is better than any single roll. These are not tricks. It is same judgment you have used for years. Here is what I want to know. Which of those three instincts has cost you the most time? 1. Trusting almost right, the output that looked fine. 2. Trusting the perfect prompt, betting it all on one all at once brief. 3. Trusting the first roll, bailing instead of rerunning. Drop 1, 2, or 3 in the comments. The answers always surprise me. The instinct that lied to me the most. Read the source and you will find one true cause. There is no source to read. The same input yields different outputs, and the output that looks most like senior work is one hiding the subtle failure. The fix? Stop hunting for one true cause. Work with variation. Loop through a couple of iterations and read for what model assumed, not just what it handed back. Two numbers worth knowing. The first one names the pain. In Stack Overflow's 2025 developer survey, 66% of developers say AI output that is almost right but not quite is their single biggest daily frustration. Not crashes, not hallucinations, the almost. That is exact failure case the deterministic instinct walks straight into. The second one is the part that should scare you. A control study from Mater had experienced developers predict AI would make them 24% faster. They came out about 19% slower and still believed it had sped them up. Read that again. They were wrong about their own speed by a lot and did not feel it. That it is the whole trap in one study. The instinct does not just lie to you, it convinces you it did not. One action this week: the next time an AI output is almost right, do not debug it like code. Instead, ask it what assumption it made. You will find the source of drift faster than any trace would. Next video, the most practical fix in this whole series is the one file that stops Claude guessing about your project, your stack, your conventions, the constraint you have learned hard way. It is called claude.md. Most engineers do not know it exists. And by the end, you will have one you can drop into your project. Subscribe if this series is useful. It builds on itself. Each video assumes you have seen the ones before.